So hi everyone, today we will be exploring a new library by NVIDIA, that is NVIDIA cuGraph, which can make your graph analytical code about 500 times faster and is a better alternate for NetworkX. So if you have been into graph analytics for some time, you might have heard of the name NetworkX, which is a quite popular library in Python for any sort of graph analytics and graph algorithms. So first of all, let's try to understand what is cuGraph, and then we will jump onto some code and real-time demo so that we can check out how we can have a performance improvement using cuGraph over NetworkX over some real-world data. You don't need to worry about any of the resources, be it the codes or the blog. Everything is present in the comment section below. So what is cuGraph? cuGraph is a set of GPU accelerated graph analytics library within Rapids project. So if you don't know about Rapids, Rapids is a specialized library by NVIDIA which provides GPU acceleration for a number of use cases, especially for pandas, machine learning algorithms, and now graph analytics. As you can see, enabling GPUs for network X with zero code change and achieving acceleration of up to 500 times over network X CPU implementation. So these are two major points. You don't need to change anything in your existing code. You just need to set one environment variable, and the acceleration achieved can be about 500 times, which is quite good because graph datasets are usually very heavy and hence are time consuming as well. Now talking about the GPU acceleration, certain salient feature of cuGraph. The GPU acceleration we have already talked about, providing about 500 times faster graph analytics. Zero code changes are required. As mentioned, you just need to set one environment variable. Scalability is very important as the acceleration is huge. Now you can work with much bigger graph datasets that can have up to 100k nodes and 1 million edges with ease. No performance degradation. And last but not the least, rich algorithm library. So basically it covers about 60 different graph analytical algorithms that includes community detection, shortest path, centrality algorithms, and whatnot. So this was a lot about the theory part of QGraph, but I am more of a coding guy. So we will be jumping on to the coding section now, and let's try out QGraph over some data sets and let's compare QGraph with network X CPU implementation. So let's get started. As already mentioned, we will be going through to analyze how using QGraph can make your graph analytics way faster as compared to using the default network X implementation. So first of all, you need to pip install nxqgraph Q12. So 12 is the newer version. And then use this particular link with the flag extra index URL. So this will install QGraph Q12. Here you can see that we are using CUDA 12.x in this particular example. You don't need to worry about the codes. All the codes are present in the comment section below for your reference. This notebook link is available there. Now, once you have installed it, you need to set up this environment variable nxqgraph autoconfig equals to true. So what happens now when you would be using network X for any of your graph analytics problem statement, by default will start using GPU. Hence, QGraph is now getting used without you just changing one environment variable. Now, let me jump onto the most crucial example on this notebook. There are many examples that you can explore. So first of all, we would be downloading this particular data set, cit-patents.csv. So as you can see, this data set consists of about 250 MBs of data. So this is a big data set. Apart from that, if you see here, this is enormously big because here you can see that it has about 3.7 million nodes and about 16.5 million edges in the graph. So it's a humongous graph. Now, if you just go with network X CPU implementation, any sort of an analytics, any running any sort of an algorithm might take a lot of time, but not with QGraph. So just to compare the two implementation, network X with CPU and network X with GPU, that is QGraph, we will be trying out the betweenness centrality algorithm. To read more about the algorithm, how it works, I have already covered that in my previous videos or even in this notebook also. They have given a detailed explanation, so you can check this out. So if you see here, when we are mentioning backend equals to network X, that means it would be using the default CPU implementation. In that case, calculating between centrality takes about 1 minute 23 seconds, that is about 83 seconds for this huge graph, as you can see. Now when we are going with the cuGraph implementation, that means we are not providing any backend parameter, hence by default it will use cuGraph. As I told you earlier, we are using a environment variable which makes sure that network X by default uses cuGraph. In that case, the time taken is just 1.28 seconds. So this is amazing. This is way faster as you have expected from network X CPU implementation. Now, if we talk about another algorithm, that is PageRank, I think you might have heard of PageRank, by which Google used to use for its search engine. When we are using network X as backend, that is again the CPU part, it takes 2 minutes 4 seconds on the same data, while the cuGraph implementation takes just 1.22 seconds. So this is making the implementation about 100 times faster in this case. So as I already told you, the acceleration will depend upon the dataset being used, the hardware being used, the algorithm being implemented, but it will give you massive acceleration. Now, one query that might come to your mind is that acceleration is fine, but how do we know that the results are accurate in both the case? So in this case, we will compare the results of PageRank for both the implementations. The first one being the network X CPU implementation and the other being the cuGraph implementation. So if you see here, after implementing PageRank, if you see, whatever are the top 5 nodes are same as what comes in the cuGraph implementation. The nodes are same, hence same ranking has been given. There might be minor issues, minor discrepancies between the two implementation when talking about the page rank value. So, but these are again negligible, so we can ignore that. Similarly, when we are talking about the bottom 5 in the page rank implementation, bottom 5 nodes, I assume that you might be knowing about page rank and betweenness centrality. If you don't, this notebook is quite helpful. They have provided everything in detail, and I have already covered all those algorithms in my graph analytics playlist, so you can check that out as well. So here you can see that again the bottom 5 are also the same. That means implementation wise, in terms of performance and in terms of accuracy, any day cuGraph is beating network X. So this looks amazing. So we have seen that how in terms of both performance and accuracy, cuGraph is the go-to solution now. Now one issue that the team has mentioned is that when we are using cuGraph with a small dataset, then it might be the case that you won't get the desired results and the cuGraph implementation might be a little slow. So considering this default example from Network X, the Karate Club graph, if you are into graph analytics, I think you might have heard of this dataset. It is very similar to Titanic for classification. So Karate Club is the Titanic for graph analytics. So here you can see that the number of nodes and the number of edges are quite low, 34 and 78. So when we go for the implementation with network X default implementation, if you see here, the default implementation gives us about 19.8 milliseconds. So this is way small. This is on the CPU implementation. While when we use the GPU implementation, that is cuGraph, it is going for 923 milliseconds. This is very high. Now the team has mentioned at one point in the notebook itself, you may have noticed that using default implementation was slightly faster. This is not surprising when working with a graph which is small, since the overhead of launching the algorithm kernel on GPU is more than the computation time itself. So very easy, like explaining in easy terms, when the time taken is very small, I think initializing the GPU takes some time for the cuGraph implementation. Hence, cuGraph might not give you desired results when you're working with a small graph data set, but when you're going with huge data sets, like as we saw in the first example, you can see significant differences. So I hope that this tutorial was useful. So while summarizing, cuGraph is again the GPU implementation of network X. You just need to add one environment variable and you're good to go to use network X with GPU. As you saw, the performance can be improved by about 500 times at times, or on an average of 50 to 100 times very easily. And QGraph may not be the best solution if you go with a small data set. I hope you understood about QGraph, and it's worth trying out. The notebook is hosted for free on Google Colab. The link is present in the comment section. You can go and check it out and play around with QGraph. I hope this was useful and you try using QGraph for your graph analytic problem statements. Thank you so much.